Somewhere at the edge of our solar system, there may be a massive hidden world that no telescope has ever captured, and some of the most recent discoveries suggest it possibly never existed at all, or if it did, it was quietly thrown out into the darkness of the galaxy billions of years ago. If that sounds like the kind of mystery you want to explore, hit subscribe right now because we cover discoveries just like this every single day, and there is always something new to uncover. To understand why this matters, we first have to go back to one of the strangest objects ever found in our solar system, a dwarf planet called Sedna, officially catalogued as Minor Planet 90,377. It was discovered back in 2003 and captured in the image you are likely seeing right now, taken by the Hubble Space Telescope. Sedna is apparently comparable to Pluto in many ways, though somewhat smaller, with a diameter of around 1,000 kilometers. It seems to be one of the reddest objects we have ever observed in the solar system, possibly resembling something like a deep rust-colored world. Its surface, beyond water ice, appears to contain methane and nitrogen ices covered in compounds called tholins, substances that seem to form when an object is exposed to ultraviolet radiation from the sun over billions of years. But what makes Sedna genuinely strange is not its color or its composition, it is where it sits in the solar system. Most objects we know of are gravitationally influenced by something nearby. Pluto, for example, is kept in a pattern by Neptune's gravity. Sedna, however, was originally classified as a member of the scattered disk, but has since been reclassified as the prototype of a group known as sednoids, bodies that are apparently too distant to be influenced by Neptune and are essentially detached from the rest of the solar system entirely. Its closest approach to the Sun sits at around 76 astronomical units, which is roughly twice as far as Neptune. But at its most distant point, Sedna reaches a staggering 937 astronomical units away, giving it one of the most extreme orbits we have ever documented. Because nothing close enough seems capable of pulling it into such an eccentric path, the natural first explanation was that something else, something large and hidden, must have been responsible. This was one of the earliest clues pointing toward the possible existence of another planet, somewhere far beyond the known solar system. For a long time, only a few such objects were known, including one nicknamed Biden and another now referred to as Laocoona, a Hawaiian name that is admittedly difficult to pronounce. Then, in 2016, a group of astronomers proposed that the unusual orbits of these extreme trans-Neptunian objects could be best explained by a sizable planet hiding on the outskirts of the solar system. What made this compelling at the time was that the orbits seemed to be clustered together. They were all tilted in similar directions and made their closest approaches to the Sun in roughly the same region of space. Early mathematical models suggested the chances of this alignment happening by pure coincidence were around 0.7%. The proposed planet, estimated at somewhere between 5 and 10 Earth masses, was apparently shepherding these smaller objects into their unusual paths. That is the core of what became known as the Planet 9 hypothesis. But despite approximately 10 years of dedicated searching, instead of finding this hidden world, researchers began discovering objects that seemed to challenge and possibly contradict the hypothesis entirely. One of the most significant of these was an object called 2017 OF201, a dwarf planet candidate roughly 700 kilometers across, with an orbit so wide it apparently takes around 24,000 years to complete a single trip around the Sun, making it even more extreme than Sedna. At first glance, it might seem to fit the expected pattern, but when scientists ran computer simulations to test what would happen to this object if Planet 9 actually existed at the distances currently predicted, they found that it would likely eject this object completely out of the solar system within just a few 100 million years. In other words, the object should not still be here if Planet 9 is where we think it might be. And yet there it is. Then, in 2025, researchers discovered yet another object, 2023 KQ14, now referred to as Ammonite. This one is important for a slightly different reason. It fills what scientists had previously assumed was a gap where no dwarf planet should be possible, based on our existing models of how sednoids behave. Like the earlier outlier, Ammonite's orbit points in the opposite direction to the original cluster of objects used to support the Planet 9 hypothesis. If the planet is there where we currently predict, Ammonite should not exist in its current state either. This finding recently passed a rigorous peer review and was officially published in Nature Astronomy, making it a formally recognized challenge to a decade-old idea. So what does this all mean? Can Planet 9 still be out there somewhere? Possibly, but if it is, it would have to be much farther away than any current estimates suggest, far enough that it would not disturb objects like Ammonite or 2017 OF201. The problem with that, however, is that a planet sitting so far from the Sun might not have enough gravitational influence to produce the orbital patterns we see in sednoids in the first place, and beyond that, at such enormous distances, repeated close approaches by passing stars over the last 4.5 billion years would quite possibly have knocked such a planet out of the solar system long ago. This is why these discoveries matter so deeply. They are not simply challenging one hypothesis, they are forcing us to rethink the entire picture of how the outer solar system formed and what shapes the strange orbits we observe. Several alternative explanations are now being seriously considered. One is the ejected architect hypothesis, where Planet 9 possibly existed early in the solar system's history, did influence these orbits, but was eventually kicked out by gravitational disturbances, and is now simply a rogue planet wandering through interstellar space. This is not an outlandish idea. Modern simulations of the early solar system suggest that at least 2 additional planets may have existed in the inner solar system before being ejected. Another explanation involves stellar flybys, ancient stars passing close enough to our solar system to have pulled objects like Sedna into their stretched orbits billions of years ago. We apparently have some evidence that such encounters have happened, and even that some were close enough to have been witnessed by early humans. Then there are galactic tides, the slow gravitational influence of the galaxy itself, and specifically its central regions, continuously tugging on everything in the solar system. Over billions of years, this force could gradually reshape orbits in subtle but significant ways. There is also the possibility that the collective gravity of all the small bodies in the Kuiper belt and the Oort cloud, countless comets, asteroids, and icy objects, adds up to enough combined mass to pull distant objects into these extreme paths over time. None of these explanations fully account for everything we observe. As of mid-2026, there is still no single clean answer that explains all of the strange orbits we have found. Finding a hidden planet would certainly be the most exciting resolution, a lost sibling world tucked away in the dark. But right now, the alternative explanations seem, at least slightly, more consistent with what we are discovering. The good news is that we may not have to wait too long for better answers. Telescopes like the Vera Rubin Observatory are already conducting powerful surveys of the sky, discovering objects that were previously far too faint to detect. It has already made many new finds, though mostly asteroids rather than mysterious planets. Some earlier observations hinted at possible Planet 9 candidates, but as of 2026, none of those have been confirmed. The outer solar system still holds more questions than answers, and the story of these distant, strange little worlds is still being written, one discovery at a time.